Welcome to yet another update video about my DIY battery tab welder. I'll do another update because I seem to be getting loads and loads of questions about it. Apparently I wasn't explicit enough before, so I'm using this video to answer some of the most asked questions on the videos. Just take you through the setup again. It has changed slightly from the last one. I've upgraded the battery, and also swapped around the switch, and these electrodes are upgraded as well, which I'll show you what they are in a minute. But basically, this is the setup. So we have negative terminal here on this particular battery. It's the other way around to what I had before. So we have negative terminal. We have the positive terminal. Off of the positive terminal comes a copper bar, which just connects to the side of the relay. Any side of the relay is fine, doesn't matter, because all the relay doing is literally bridging the connection between this terminal and this terminal inside here. So yeah, it doesn't matter which way around these go, and also it doesn't matter which way around these wires go, which is these are the 12-volt feed to this solenoid here. Okay, so as soon as you put 12 volts onto this solenoid, the coil will activate and the switch will basically just go and close the terminal, and as soon as you take off the 12 volts, it springs back again. And this can happen really, really quickly, which is ideal for this particular application. Now, so coming off of the solenoid, we have this 16mm squared, pretty solid core copper cable coming from the positive. That goes to this, what we call in England a chock box, but it's just basically an electrical connector. They come in strips. They can be sort of yay long. You just cut off the ones how long you want them to be. And then underneath, on this side, we have 2 copper rods screwed in to these terminals, and that's what actually makes the connection on the nickel strips. And if we just go back over to this side, so we've got the negative coming off of here and going down to this side. So what happens is when you bridge the connection, it basically shorts the battery. Okay, so literally you have all the current that the battery can provide going through this cable, down through the nickel strip and back up through that cable. It does not penetrate the cell. It literally just does not penetrate the cell. It hits the surface and it comes back straight back out again, back up through the copper rod. So it does not damage the 18650 cell or any particular cell that you want to weld with nickel strips. You can do it with AA's, you can do it with AAA's, you can do it with anything like that. And that's absolutely fine. So the switch setup for the solenoid is as follows. Okay, so at the moment this particular solenoid has a red cable and that's green and yellow, I think. So I assume that the red will be positive and the green and yellow will be negative, or ground. I suppose green and yellow is normally ground. So what I have done is I have hooked the red wire coming out of the solenoid. Okay, you can see that here. I've hooked that directly to the positive terminal of the battery. So the positive is constantly connected. So then we take the negative wire, okay, coming from the solenoid feed, 12-volt feed, and that comes down here, swaps over into this yellow cable because the wire wasn't long enough, and that will go down here, down here, down here, and it goes eventually to one side of this switch, okay, and the other side will come back down this cable here and go up to the negative. Now all you're doing is you're breaking with this switch the negative connection. So at the moment, because that switch isn't pressed, there's no negative feed going to this solenoid. At the moment, it's always got positive, but the negative isn't. So as soon as you press this button and bridge that gap, okay, and as you can hear, you can do it very quick.
18650s are safe, but do take care, and thanks for watching.